Hello, my name is Austin Riddle, and this is my assessment of Hosley, G.W. Hill, and Shink Forests and NCSU's Lake Wheeler facility for ET 255. A bit of background: G.W. Hill Forest is a 2,450 acre forest in Durham County that is used for educational purposes by NC State's faculty, such as summer camps. Hosley Forest is a 250 acre forest in Franklin County, currently managed for both pine and bottomland hardwood trees. And Shink Forest is a 300 acre forest in Wake County that has a dual purpose of management for tree species such as Hosley and educational uses by NC State faculty, much like G.W. Hill. Also included is the Lake Wheeler Labs, a 1,500 acre field lab used by faculty for both teaching and research opportunities. For the purposes of this assessment, I've excluded two of the properties given, the first of which being Shink Forest. Shink Forest was excluded primarily due to the fact that faculty currently use it for education. Therefore, in announcing that you're going to cut it down to replace it with short rotation woody crops or soybeans, you would meet significant resistance from faculty in the College of Natural Resources. Also, the forest's current management practices provide income to NC State and its College of Natural Resources, and the land area is only 300 acres, which, when you're comparing it to a forest such as G.W. Hill, is very small, which would limit the amount yielded, and therefore the amount of energy offset by the area. Also excluded is Hosley Forest. Like Shink, Hosley is managed and therefore provides a source of income for NC State and the College of Natural Resources. And also, like Shink, its area is small, in fact, smaller than Shink's, therefore limiting yields, which therefore limit energy offsets. So, what resources should NC State use? Lake Wheeler facility can install anaerobic digesters to take advantage of the animal waste from nearby operations. And G.W. Hill Forest can grow either short rotation woody crops for electricity, soybeans for biodiesel, or maybe a combination of both. Lake Wheeler can install anaerobic digesters nearby, which could produce up to 3,800 million BTUs per year of power derived from animal waste collected from nearby sources. This equates to approximately 0.54% of NC State's annual electricity consumption, or offsetting costs by approximately $87,000 a year. Considering the number of animals nearby, there's over 6,000 of them, 2 digesters are recommended to handle the volume of waste. Therefore, this increases the cost. In a report done by the United States Department of Agriculture, it's estimated that the cost of installing electrical generation equipment ranged from $114,000 to upwards of $326,000. Therefore, at best, it could be anywhere between 2.5 to 7.5 years before the anaerobic digesters are paid off. However, it would be longer than this since the cost of adding transmission capabilities for Lake Wheeler anaerobic digesters is unknown. From a sustainability perspective, adding anaerobic digesters would disturb a very small amount of land, requiring only a few acres to work on rather than a few hundred, allowing soil erosion and pollution to be minimal. Anaerobic digesters would also reduce the use of fossil fuel-based power for NC State, equating to less carbon emissions, and the capture of animal waste and the methane from it means that methane does not go into the atmosphere, where it can act as a more potent greenhouse gas than carbon dioxide. Instead, it is combusted and turned into carbon dioxide, reducing the greenhouse gas potential. Moving on, G.W. Hill Forest can be used to grow 2 different types of crops, either by themselves, or jointly. In using the forest, I would recommend using only half of it because that balances the needs of the summer camps hosted by NC State and its faculty, while also providing bioenergy power to NC State for the future. And using short rotation woody crops, SRWC, upwards of 166,000 million BTUs per year could be produced from direct incineration, going upwards of 23.4% of NC State's annual energy consumption, or nearly $3.8 million offset a year. Cost to build facilities based on combusting SRWC starts off with buying the biobalers, the equipment used to gather the crop. And according to Anderson, a French company that sells such a product, the lifetime cost of one biobaler, accounting for loan interest, depreciation, maintenance of the machine, paying someone to drive it, fuel cost, is $224,000. On top of that, according to a book called The New Vistas in Agroforestry, in Florida, it cost $1.42 to $1.66 per gigajoule to grow, harvest, transport, and combust SRWC in Florida. If these numbers were translated to North Carolina, NC State would then have to shell out an additional $200,000 to almost $300,000 for a facility, meaning the overall total cost reaches between $425,000 and $520,000. However, once the first harvest in 4 to 5 years is collected, those initial investments can immediately be paid off, as the energy offset could be anywhere between $2 to $3 million of NC State's budget. Sustainability perspective, though, is not the best. In cutting down thousands of acres of forest, you would expose the soil to extensive erosion and add carbon emissions from decaying organic matter and equipment usage. And soil erosion would be a continuous issue, as harvesting would re-expose the soil from machines running over it and exposing it to more erosion. This can be minimized, though, by using a tree species capable of coppicing, regrowing from its stumps, such as a willow tree, which would eliminate the need for yearly reseeding, meaning soil disturbance is lessened. First-year growth of SRWC would require pesticides to ensure the stand is not outcompeted by weeds. But once the stand is established, pesticide use will decline. However, fertilizers may be needed to maintain or grow yields as NC State and the Southeast in general grows. GW Hill could also be used to produce biodiesel from soybeans. Soybean oil can be turned into biodiesel via transesterification. Such a process could produce upwards of 10,000 million British thermal units per year, equating to almost 5.5% of NC State's annual fuel use, offsetting $210,000 to $270,000 annually. The offset could be even greater if the glycerin byproduct of transesterification can be collected and sold. However, if not enough is sold, that is left over must be treated as a hazardous waste and disposed of as necessary, as mandated by the EPA. Therefore, its economic value is detracted from if the glycerin becomes a hazardous waste. And storage of the biodiesel is also very critical. You will need a container that prevents contamination by microbes, chemicals, light exposure, temperature control. Because if any of those four are not met adequately enough, the fuel will degrade in quality and cannot be used by NC State's fleet. From a sustainability perspective, carbon emissions will occur during the transformation of the forest into farmland and the use of gasoline-powered equipment to not only do the transformation, but also to apply pesticides in the future. And the fertilizers and pesticides may be required to maintain or grow yields in the soybean fields such that it can meet future demands. Thank you. That is all.